In this video, I will talk about inductive sensors. I will explain what an inductive sensor is, how an inductive sensor works, some of the different types of inductive sensors, and I will also talk about some of the ways these sensors are used in automation. If this is your first time here and you want to learn more industrial automation topics and keep your knowledge up to date, make sure to hit the subscribe button and the bell notification icon so you don't miss anything. An inductive sensor is an electronic device that can detect ferrous metal targets without physical contact. Inductive sensors will also detect non-ferrous metal targets like aluminum, brass, and copper. But using non-ferrous metal targets decreases an inductive sensor's sensing range. The sensing range of an inductive sensor is the distance from the sensor's face to the maximum distance the sensor can detect a metal target. The sensing distance can be found on the sensor's datasheet. The datasheet will also show some correction factors when you want to detect a non-ferrous metal. Non-ferrous metal is a type of metal that does not have a significant amount of iron in it. Brass, aluminum, and copper are examples of non-ferrous metals. This means these metals do not have a significant amount of iron within them. Here, for this inductive sensor, the datasheet shows the sensing distance as 12 millimeters. This works only when the object is steel, which has a significant amount of iron in it. If the object is a non-ferrous metal, meaning it does not have a significant amount of iron within it, you need to consider a simple correction factor when defining the sensing distance. For example, here it says if the object is made of brass, you simply need to multiply the normal sensing distance for the sensor by 0.5. So, if I multiply 12 millimeters by 0.5, I will end up with 6 millimeters as the sensing distance for a brass object. This means if I want to sense an object that is made of brass, the distance between the sensor and the object should not be more than 6 millimeters for this sensor to be able to sense the object. The same goes for other non-ferrous metals as well. For example, if I have an object that is made of aluminum, the sensing distance for this inductive sensor is 12 millimeters multiplied by 0.4. This gives me a sensing distance of 4.8 millimeters. For a copper object, the sensing distance will be 12 millimeters multiplied by 0.3, which is equal to 3.6 millimeters. As you can see, here it shows the correction factor for steel as 1. Steel is a ferrous metal, as it has a significant amount of iron in it. So the sensing distance for an object that is made out of steel is 12 millimeters multiplied by 1, which is equal to 12 millimeters. If you need the sensor datasheet and you cannot find it, you can go to the sensor manufacturer's website to get it. The four major external parts of an inductive sensor are the body of the sensor's face, the indicator light, and the cable end or cable connector end. Inside the sensor's body is where the circuitry that makes the sensor work is located. The face is the part of the sensor that detects the targets. The indicator light is usually near where the cable gets connected to the sensor. The indicator light turns on when the target is within the sensor's sensing range. The sensor's cable has 3 different colored wires in it: brown, blue, and black. These sensors are available with a cable that is already attached, or they can have a connector that the cable screws onto. How inductive sensors work is the sensor creates an electromagnetic field that emits from the sensor's face. Putting a metal target near the sensor's face will disrupt the electromagnetic field, causing the sensor's output and indicator light to turn on. Inductive sensors are available in a lot of different configurations. They can be AC or DC, shielded or unshielded, normally open or normally closed, NPN or PNP, just to name a few. They also make inductive sensors for hazardous, high temperature, and washdown locations. For washdown locations, we need to use a shielded inductive sensor. Here are some advantages of using inductive sensors compared to other types of sensors. Inductive sensors are solid state and do not have any moving parts. This makes them very reliable because they usually only need to be replaced when they get physically damaged. Inductive sensors can get dirty and still work. Things like dirt, sawdust, oil, and grease will not affect how inductive sensors detect targets. Inductive sensors can also be mounted in many different ways. Depending on the type, some of these sensors can be mounted by just bolting them in place or drilling and tapping a hole that is the same size and thread as the sensor. They also make a lot of different factory mounts for inductive sensors to make them quick and easy to install. For my example, I will be using a general-purpose 24-volt DC 12mm inductive sensor that is normally open and has a 3-wire cable already attached. I will use a bolt to trigger the sensor. To connect the sensor to the tester, connect the brown wire to the sensor voltage positive terminal, connect the blue wire to the sensor voltage negative terminal, and connect the black wire to the sensor output's number 1 or number 2 terminal. Now, let's see how an inductive sensor works. Notice when the bolt and sensor are not close together, the indicator light is off. When I move the bolt into the inductive sensor's sensing range, the indicator light turns on and stays on. Notice if I move the bolt so that it is touching the sensor, the indicator light stays on. When I move the bolt away from the sensor, the indicator light turns off. If this sensor's output was normally closed, the indicator light would be turned off when the bolt is at the sensor, and the light would be turned on when the bolt is away from the sensor. Now, let's talk about some examples of how inductive sensors are used with automation. Inductive sensors can be used to detect part in place at workstations, at conveyor stops, and even at robots. They can be used to detect if an air cylinder is extended or retracted, and if a pallet stop or chain transfer is raised or lowered. Inductive sensors can be used to detect if a pallet is centered on a turntable before it starts to rotate. Let's say this turntable is rotated by a motor with a gearbox and the motor is controlled by a VFD, or variable frequency drive. Inductive sensors can be used to tell the VFD when to slow down and stop. In review, by watching this video, you have learned about inductive sensors, that they detect metal targets without physical contact by creating an electromagnetic field. You learned the 4 main parts of an inductive sensor, and that they have many different options to fit the needs of most applications. That should do it for this video. Please let us know if you have any questions about inductive sensors in the comments below. Also, make sure to like this video if you found it helpful. This will help other automation engineers like you find this video. Thanks for watching. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.